Hello and welcome to another Into the Terminal. Today, we're going to be finding out all about find.
We're finding the finds and and all the finds.
I don't
I heard you
know.
like find.
What are we finding with find today?
Well, primarily files, I think, and directories.
Yeah, so why don't we jump into the terminal and we'll start
Yeah.
with our first batch of find options.
Let's
All
get
right,
into the
so
term.
yeah, find is for finding files on your system. And so you could do things like find by name. And I need to tell it where to look. So I'm going to look over the entire system. I'm going to start at the slash, the topmost directory on the machine, and work all the way down, looking for files that have this in their name. Or actually, they're named exactly this. So how about I put some wildcards around it? So I can get things that have this somewhere in their name.
And it's worth noting you put those quotes around it because otherwise Bash was going to automatically extrapolate the stars. Find is weird like that. You either need to escape it or put it inside those single quotes. Otherwise, it treats it badly.
Yeah, and it's actually not Find's fault that occurs. It's really the
Right.
Bash shell's fault. As it's doing its command line parsing, it sees that star character, which is a wildcard for the shell, and automatically expands it before it executes the holding find command. So
Right.
putting it in quotes helps Bash parse things in the right order that you intend, right?
I call it out only because early in my sysadmin career, it always tripped me up. So
Yeah, for
if
sure.
you're learning fine from us, now you know why why you have to do that.
And so you can see all these files that got listed over the entire system have the term HTTPD somewhere in their file name string. Some of it begins the string. Others, it's kind of like in the, actually, all these have it in the beginning of the string. Let's see if I scroll up a little bit. Well, that's it. It's all in the beginning, just because that's how things got named today, I guess. Um, but if we actually, here, let's do this.
Try a more
Touch.
generic term that might. Oh, okay, there you go.
Boom. So I just created one that has HTTP at the end. And when we find it, should be in /root. There you go.
There you
So
go.
yeah, it doesn't matter where that term exists because I put a star on either side. It'll find a file with this string somewhere within it. All right. But I created a whole bunch of things today for us to fool around with. So I'm going to be the normal everyday RHEL user, and I have this directory of files, right, that I made. And we're going to do a find.
You have a lot more files than I made. You went like all out on this.
Yeah,
Scott's the
man.
overachiever in today's episode.
I like find. Find is my jam. All right, so we'll look for names of files that start with file. Notice, unlike last time, I didn't put a starting directory in it. I didn't say look
Right.
over the entire system. I didn't reference a starting directory at all. So it uses my current working directory as the starting directory. So there's my list of files. But I'm pretty sure I created 150 files, and I don't see 150 files listed here. So the reason for that is I used a slightly different find command. So when I do this, you'll notice that one of my files, where it is, there it is, bink. One of my files has a name that begins with the capitalized F. But when I told it the file name that I'm looking for, I used a lowercase f. So originally it was like it skipped that one with the capital F because it didn't match the find command I was looking for. So what I did was I changed the name option to instead be the iname option, the case insensitive name. So it doesn't matter whether it's capital or lower, it'll find it. And that's where my extra 150th file came from.
The secret capital
That's
F
right.
file.
That's right. I
Yeah.
did all kinds of things today, Nate, to like break different stuff and like make things searchable or not searchable. It's crazy town.
Well, I learned something
So-
new, and I'll talk about it during my demo. But
okay.
2 things new, actually.
The other thing that I often find is that when I'm looking for files, I generate the list of files, but I'm probably interested in other properties of those files too. So another option that I use with find a lot is -ls. And what it does is it shows me a long listing style output that includes the inode number, permissions, ownerships, size, last modified timestamp, and file name. So that is just built into find -ls, and it'll do this long listing style output. The other thing that I use a lot is finding files by size, especially when file system space is tight. And so you can see one of my files there is really big, so it kind of ruins the surprise. But I could do a
And you didn't
find.
see that one.
That's right. Dash size plus 2G. So this is looking for files that are over 2 gigs in size. Right. And it's able to find that one. And, we'll throw on that -ls so that I can look at the actual size of it. Right. You have to be a little bit careful with size because the prefix before your actual size you're looking for tells it a little bit of metadata. So plus says, I want something that's more than this big. So if a file was exactly 2 gig, it actually wouldn't find it. There's also minus, so you can say less than this size, which I found less useful because usually I'm looking for big things, not for things smaller than something. And then the one mistake that I see people make all the time, they do this.
And that's exactly 2 gig, isn't it?
Yes, that is exactly 2 gig. And so because my file was bigger than that, it didn't show up in the output because it was bigger than 2 gig, not exactly 2 gig.
Yeah, and those pluses and minuses work for other searches in Find, where the minus does make more sense. And I'll show some of those later.
My last thing I want to talk about is you can logically group things together. So if we put more search criteria, like let's also throw in a -i name. So if you have a whole bunch of search criteria on your find command, you are logically anding these things together. So the files that are going to be reported by find match all of these criteria. So it has to be a file name that starts with file something. It has to be larger than 2 gig. And if it meets those criteria, we will also ls it. One of the other things that you can do is change that from anding all of your criteria together to providing logical ORs. So if you use the -o option, now what we're saying is find me case insensitive names of file something or files that are greater 2 gig, regardless of what their name is. So you can build like either super exact things you're looking for by anding all your stuff together, or you can provide a list of criteria. Either of them would be acceptable for find to locate and display your file that you're looking for. And I'll get into a little bit more towards the end of the episode on this because like you can get pretty complex in this, and there's some times where like that actually might be required to get the actual output out of find that you want.
Yeah, the chaining of those filters together is something that I've done a lot of, and they're in my examples too. And I think it's probably a pretty common use for find.
Yeah, and so we could do something like this. File 7 star. Oh. Right, so now if it's file 2 something, file 7 something, or is larger than 2 gig, then then print it out. So these are the files that are 2 something. These are the files that are 7 something. And then, yeah, I think my file that was too big, it was file 20 was the big one. So it would have been matched by that file 2 something criteria.
Right.
Yeah. So that's getting started with find, Nate. Anything else before I tell them about what's coming up after the transition?
No, just that we're gonna have a ton of find today. Ton of finding things. Lots of all the
Yeah.
finds.
I was hoping to get to 50 different find commands, but I think I only got us up to like 30 something
Man,
find
I don't know
commands.
what it is that you have against us having time to eat lunch between this and our next meeting.
I just love big numbers, Nate. I like large amounts of things. So we're going to transition. We're talking a lot more about find and show like a whole bunch more of the different ways that you can put criteria into your find commands to locate certain things. We're also going to talk about executing commands on the things you
Yep.
find.
Yep.
We're also going to talk about um, uh, dealing with some weird things on your system but using find in order to help you deal with them. And then I'll also have a couple of small things like making reports and maybe some security related finds that we might be interested in. So don't forget to mash that like and subscribe. And we will be right back after this little transition anime. And then we will jump back into find.
Telling you, commercials. We need commercials. It's like a short 10-second, completely hilarious, nothing true commercial. That would be so much better than just whoosh.
Fair enough. So, Nate, we're doing more find.
We're doing more find. Yeah. I guess we'll just jump right back into my finds because I don't know that we have much more to talk about other than what you already did there. So here we go.
I mean, it is called Into the Terminal.
Into the terminal. We're going to spend a lot of terminals. There's no whiteboards today. So, all right. So I've got a couple examples. The thing I used find for, I think, the most in my sysadmin career was to find files that were of a certain age, usually because they're filling up a disk or something. And you're like, you know what? Everything older than 30 days, I can just drop. Or whatever, right? Rotating log files, stuff like that, stuff that isn't automatically rotated. So I have a couple that are time related, which is the first thing I learned today. The touch command can change the modified time to whatever you want it to be on a file. I didn't know that. Here, have a look at my files here. See how I've got one that's in 2023? Well, I did not go back in time and create a file from in 2023. That I was able to use touch. There's a touch -d command that lets you change that metadata. Crazy. Like I didn't know you could do that. So
No.
anyway,
Nate, that can't possibly be true. Last year, we decided that we were going to do this episode in a year, and we touched a file on a machine, and we kept that machine around for a year just so we could do this gig.
right. Yeah, that's exactly how that worked. Ignore everything I just said. All right. So anyway, so those filters with find that Scott was already touching on in the critical path. There's one called M time, which is the modified time, and there's other derivatives of M time. There's like a creation time, I think, and wasn't there an A time, like access time? I'd have
That's
to go look
correct.
all those up again. But so you can filter on other time related things, like when was a file accessed or whatever. I'm going on when they were modified because that's most commonly what I think people care about. So if we do a find, and there was a comment in the chat that you probably missed while you're doing your demo. Rick and I both had no idea that if you're working in the current directory, you did not have to specify a directory. We've always used find dot and then the thing. So 3 things I learned today: touch, the working directory, and then there's one more that we'll talk about as I get further on in the demos. All right, so -m time is modified time. And then you can use that same plus and minus syntax that Scott was using before. So this goes based on days. I don't know if I can go. Can it be filtered in things other than days? Maybe you know,
It can,
Scott.
but you have to use extra criteria like
Okay.
+1H or something like that. It's
Yeah,
been a long time since I've done it, so don't
I
like
I
live demo
tried
me.
I tried to do like I wanted to specify days or hours or whatever, and I just couldn't figure it out. So anyway, it's there. I just didn't take the time to figure it out. So
Yeah.
M time +1 says things that are older than a day, right? Things that are before a day. And I'm going to do another M time, and we're going to do -5. So things that are younger than 5 days, right? So anything that's between what 5 and 1 days old should show up in my list here, right? And there we go. We have two files. There's file2 and elif2, which is just file spelled backwards because I needed a different file name for my later example.
So Nate, do you know where I use a find command like this all the time?
Where?
When I'm doing troubleshooting challenges. Like you walk up to a booth or something and they're like, hey, fix my broken machine. You're like, cool. Let me see what you've changed recently on the machine. And that'll
There
tell
you
me
go.
where I need to look.
That's a perfect use case. Don't be ruining it though, because
Well,
anyway.
Now we can modify the time
Now we can
and like set it back in time and like totally break that cheat.
That won't work anymore, folks. Don't try it. All right. So back on task here. So obviously, all I did was find the things and show them to you. Now, there's another command, and I think Scott showed this earlier. You use -ls. I usually use -print, which just prints it to the screen here, because there's sometimes you'll run a different subcommand of find. For example, if I did delete on these files, -delete will simply say everything I find that matches this, delete it. But if I do that, it doesn't actually give me any output, right? So if I were to do that, I can't do it again now because it won't actually find anything. But if I added a -print to this, then what it would do is everything it deletes, it'll also show me what it's deleting. Now, when you're doing this in like an automated fashion, you probably don't want it to print the output. You just want it to do the thing you asked it to do, which is probably why that's the default. But keep in mind that if you're trying to execute, it's actually also two benefits here. If you're trying to test the command before you actually execute the deletions, use -print instead of -delete. Because then it'll tell you, like, it'll give you the exact same command you were going to run. Instead of doing something, it'll print out the files that it's going to act on, right? If you need a log of what was deleted, add the -print after the -delete. And like I said, it's not going to show me anything here because I already deleted the files. But if I had not deleted them yet, it would have printed them as it was deleting them. So I would know what it deleted, right? So keep that in mind. I think that's a useful tool. Let's see here. Another example I have is what if I wanted to find, again, based on some criteria, I'm going to use the same time-based commands, and I want to modify those files. Like I want to change the contents of a file. So here, let me get my thing, and then we're going to cat one of these files, and you'll see what's in them. Oh, I need a number there. They just have a couple colors and the word dingo. And the word dingo was actually part of the description of today's video, which apparently didn't get pushed out. If anyone's looking at this video, they'll see the description still says we're talking about UBI. That was last week. You fixed it. Good. Okay, so go look at the description now and you'll see why I said dingo. But so all these files have the same text in them. If I just did like a cat file star, you'll see they're all the same content. But what I'm going to do is I'm going to run a command that will find all of them that were modified between 1 day and 60 days, right? And then we're going to exec sed on them, right? We're going to do a sed in place, and we're going to swap the word green for the word orange, right? And you know what? Just for fun, if I can show you which ones are going to get modified and show you that print command by adding -print.
Before you actually, we did have one request from Shantanu earlier in the stream, which is we're doing exec. Exec actually has a very specific convention of syntax that it has to have, right?
It does. So and yes, so, we can step through that. I meant to step through that and I forgot. Thank you for reminding me. So yes, with exec, what you do is you basically enter in your command the same way that you would, but you need some way to substitute, or I guess not substitute, but some way to insert the thing that it's supposed to execute on. And that's what these two curly braces are for, right? So two curly braces right next to each other, that's a substitution that says, okay, the thing that you found, put that path and file name right here. So I'm using sed in place, and then the curly braces will be the thing that it's executing on, right? And then you have to terminate the command, right? Because I guess you could exec more than one at a time. Maybe that's why you have to terminate it. I don't know. But you have to terminate the command with a semicolon. But just like with the stars that Scott had to put inside of single quotes earlier, or you'd have to escape. Bash will interpret that semicolon as the end of the line, right? So you have to escape the semicolon in order to send it to bash, or not send it to bash, send it to find and the exec command so that it treats it as the end of the line. So that's that funny syntax we were talking about. All right, so I'm going to run that, and you can see that it touched file 3 and elif3. And if I do cat file star now, we should see that the word green was changed in one of the 3 files. And the same thing if I did the ELIF star, right? The word green has been changed to orange, right? So that's, again, a good way to like, and you can craft any manner of criteria for what you want that file to be that it found, and then execute the command. And in fact, I'm going to, I have another command in a little bit where we're going to not only find specific files, we're also going to use sed to replace a name in it, and we're also going to execute a command that will change the file name, right? So we can do all that in one command, which kind of shows the power of what find can do here. Now, the other thing I wanted to cook up was what if I wanted to find files containing a text string? And I started looking into, can I do this with find? And I realized, why would I do that when I have grep? Right?
Right. Like, why? Nate, you love making things needlessly complicated. Let's throw more commands into something you could do more simply.
Right. So if I do a grep-r for the word orange in the working directory, it'll find everything that has the word orange in it, right? So there was really no reason to do this with find. So I just did it with grep because grep is exactly what this is for. So there's your bonus for today. It's not a find command, it's a grep-r. And you can also do that case insensitively if you want to with a -i, grep-ri. So if the word orange had a capital O or something, then there you go. So there's your bonus for today. And then the last example that I have in my series here are this complicated one that I was talking about. And this is the third thing that I learned today, which was how to use the bash rename command. So we're going to paste this in here and I'll walk through it here quick. So we're going to use find. We're going to find all the files named elif star. And again, I escaped the star where Scott put it inside of quotes. You can do it either way, right? Then we're going to execute sed-i. We're going to swap the word dingo for the word kangaroo because we're staying in Australia here for whatever reason. We're going to use that same curly braces syntax to say what file to execute that on. And then I add the semicolon, and I added a second exec, but now I'm curious if I dropped the second -exec, would it just run the 2 commands separated by the semicolon? But I don't want to break my demo. So I'm going to run a second exec here, and we're going to use rename. And the way rename works, and this is what I learned, is you can say rename files based on a pattern, right? So I'm renaming files based on the pattern elif, right? Because that's the thing that's currently in the file. I'm going to replace elif with foo, right? And then I'm going to do it on the file that it found, right? And again, I could add a print in here if you wanted to see what it was doing, but I don't want to mess this up. So we're going to hit enter. And if I do an ls-l again, you're going to see all of the elif files are now renamed as foo. And the word dingo is replaced with kangaroo. If I look at file 1, it shouldn't be replaced, right? Dingo is still there. And the other cool thing is it should have gone into this subdirectory here and done the same thing, right? So you can see all the elif files that were in here are now renamed to foo. And dingo is renamed to kangaroo, right? So both the power and the possible pitfalls of find, if you're in a working directory, remember that this is going to dive into those subdirectories because that's what find is made to do. I don't know if there's a don't descend to subdirectories command for find. I'd have to look into that.
There is.
I'm sure there is.
It says depth, I think is the name of the option. But there's a couple different ways that one could control like how wide and deep find goes when looking for files.
Right, right.
You asked about if you didn't escape the semicolon, if it would just run. No, it would break.
Yeah, well, what I meant was if I took this command up here and not if I didn't escape the semicolon. If I took out this word exec,
Oh,
if I
no.
did it like this and strung the two together, would it execute both?
I don't think so, because you have that semicolon that was escaped that terminated your exec statement, right? So
Right.
there's no leading exec to tell it the next thing is also an exec statement.
So I mean, we're gonna find out, I think, because this is my last demo, and I don't mind if I break my machine at this point. So we're gonna change this from elif to file, because those are the ones I didn't touch yet. And then we're gonna change this from elif to file, and we're gonna see if they both execute. Anybody want to take any bets? All right, maybe not. Yeah, there you go. Must proceed expression rename. So yes, you have to use the dash exec for each one. So why the hell does it need the semicolon? I guess that's just so it knows where the end is, I suppose.
The semicolon is the end of your exec, right? So you
Yeah.
open the list of commands that you want to run with your exec, and then you close it with the with the semicolon. What you could have done, you could have you might have been able to take out the no. I'm sure there is a way to like combine multiple executions on the same thing. I think it's just a syntax thing of like us trying to do it, right?
Yeah. Now, one thing I will call out, and this, whenever you look up find commands for how to do things, you're going to find a dozen ways to get the same thing done. And the reason for that is find has a bunch of these subarguments that will execute things that you could also do with bash, right? If you execute them with bash, then what find does is every file that it finds, it calls up a new process to do the exec. So in this case, when it ran, it would have called two separate processes, one to do the sed and one to do the rename, right? And if you're dealing with thousands of files, that could quickly tax your system. And a lot of experienced systems administrators will say, don't use exec unless you have to, especially if you're dealing with a lot of files. So just keep that in mind. The exec command is powerful, but it can also really be detrimental to your system when you're dealing with a whole lot of files. So like if I
Nate,
had done something that would touch everyone and use grep to find something, right? And it's going through thousands and thousands of files, it's going to open thousands and thousands of instances of grep, which is not okay.
I disagree. It's 2025. Like, nobody cares about CPU usage anymore. It's not like back we had single core Pentiums or something silly that we were running Linux on.
But go look up anything, any examples of find commands, and you will always find someone in the comments. Do it this way; it'll open less processes. So now you know. All right, that's the end of my demo.
But wait, there's more find.
Of course, there's more find because Scott's the overachiever today. By the way, we're already at 30 minutes, so you know, just saying.
Hey, you can never have enough find. We
enough.
promised to plumb the depths of find, and I will comply with our promise.
We will do that.
All right. So I've just put down a couple other things that I use find for periodically. So for example, it might be interesting to find files that have specific permissions, right? Like we know about the evil permissions. Are there files that have the evil permissions? Why, yes, there are files that have the evil permissions. So you could do that.
So strange that somebody would have done that as if they had crafted it just for this demo.
Exactly. And this is looking for the exact permissions: read write for the owner, read write for the group, read write for others. More explicitly, maybe we don't care about read write for user and group, but we'd maybe care about read write for others. So instead of asking for a specific set of permissions, you could do something like the ones where others have write permission, right? And so that'll give you slightly different results. I actually made this one, file 66. Actually, let's do this, -ls. I made file 66. It's a symbolic link, so it has all the permissions. And then there was one up here. There was one somewhere. There he is. File 149. I specifically took away the permissions from the group so it wouldn't show up in the 666 permissions find, right? But does show up in the others have read write permission find, or have write permission find. Similarly, you could say, hey, where Where do others have execute? Show me those files where others have the execute permission. That might not be something that we're interested in having. We can even apply this to special permissions, right? So if we do a find perm u plus s, these are all my files that have SUID, right? And if I do the -ls, right, they have SUID. Those are weird file permissions that I don't necessarily want files to be running around with. And you could even use things like exec to fix that. Right, so find the files that have SUID and then just turn it off, right? So if I find those files again, nothing's there because I turned it all off and they no longer match the criteria that I'm looking for in my list of files. I mentioned one of my files is a link, right? And we see that when we just, helps if you type in the right terminal. File 66 here is a symbolic link. We see that from colorized ls, but we can also look for files of certain types. Show me files of type L, which is symbolic link. We could also say type F, which is regular file, or type D, which is a directory. And so that's one way that you can find symbolic links that might be around in your directory tree that you've pointed find at. One that's a little bit more difficult to find, however, are hard links. So symbolic links actually tell you, when you long list them, where they are symbolically linked to, right? This Etsy httpd.conf, httpd.conf. When I access file 66, that's where my command that's using file 66 really goes. But hard links are where somebody creates a directory entry listing for your file somewhere, but it actually only has one copy of the file on disk, and essentially they share the same inode number or file pointer number. And those are much more difficult to find. So I've done stuff in the past like, where is it? If I do this, I can get the inode number for a file that I'm concerned has hard links made to it. And I get the unique ID of the file pointer on disk where this file resides. And then I can use find with that inode number, and we'll actually search over the entire system for 346-947-65. And I'll just
That doesn't like copy and paste, apparently.
All right. So there's actually two files that share this inode number. One is the original that I was looking at, my httpd.conf file, but then somebody made a hard link, file 76, to this file. So if I remove httpd.conf, it actually doesn't get removed from the system because there's another pointer to it elsewhere in the directory tree that keeps it stored on disk. And that might be something that we're not very interested in. So that's how you can find all of the hard links to a file on your system, by finding based off its inode number. All right, another place that I've used find, super annoying file names, right? Like this guy.
Quick question for you. Shantanu asked about type D and F. Did you, or are you going to cover those?
I just did.
Well, you covered L. Did you cover F and D? Maybe we both missed it because we were busy chatting. Sorry about that.
There you go. Not paying attention. If you do a find -type D, right?
Yeah.
Those are your directories.
Okay.
Find
there you go.
-type F. Those are your regular files. You can actually do C and D. Basically, if you do this leading character tells you what kind of file it is. So you can see a D for a directory. Up here, there's an L for symbolic link. named pipes, character devices, block devices, they have their own types too. So if you do a dash type and you put in that leading character, it'll find files of that type that correspond with like what we'd see in the LS output. F is the only one that we don't see in the LS output because that's the default, right? There's
It's
no
just the
file
assumed
type.
one. Okay, makes sense.
All right.
Okay,
So,
thank you.
Yes. All right. So the other place where I use find a lot is these obnoxiously named files. And so if we do something like that, right? Actually, I will do a long listing because I'm interested in this one file. But is it really going to give me that one file?
No, it's not.
No. Because it's going to give me all the files, right? Because it said star. It got interpreted by the shell as a wildcard. And worse, -R, right? That didn't work at all. Or if I just want a regular ls, it doesn't work because -R is like it's being seen as a option. And -R is actually the worst because you can even do things like escape it, but it will still assume that you mean -R.
Yep. Shantanu wants to see you delete star by trying to delete star.
I'm gonna.
I know you're gonna.
A lot of times these files get created because like you were touching something or you wrote a script that did something weird and now these extra things are around. But they're difficult to work with because of their special formatting and how the shell interprets them. And if you just try to remove it, bad things would happen, right? Which is why Shantanu is taunting me.
Right.
So this is what I use find for. All right. So I can do something like find -name star, right? And there's the file that I find.
Look at that.
And then we'll just
do -delete, couldn't you?
I could, but I didn't know -delete until today, Nate.
You learned something too. I feel good about myself.
I did. All right. So notice that after I remove it, it gets deleted, right? When I do my find, it's no longer found because even if I look, right, it was up here in the top corner, it's gone. I successfully deleted it. And we can do the same thing for -R, right? So we could do something like R, right? Boom. Oh, wait. Oh,
Didn't work for delete.
Yeah, because again, like it's interpreting it as a option.
Yeah. Well, wouldn't RM also interpret it as an option then, or no?
It would. It would. This is like the most obnoxious of all mistakenly named files.
And we all know that RM-R is totally safe.
Totally safe. No. So this is another place where I use inode number all the time, right? So we really want this file. So you look up its inode number and then you tell find to find it by its inode number and then delete it. So it doesn't even use the file name.
There you go.
It deletes it by its inode number. All right. Cool. Couple more. One find that I use fairly often is I want to find things on my system that are owned by a certain person. Right. So I can do something like as root. Look over the entire system. And we'll redirect out error messages because I don't want to see them. So here's all the files on the entire system that are owned by this person. If I did it as this person, it would be kind of messy.
Right, because there's a bunch of stuff it doesn't have access to.
Here we go. It's kind of messy because as a logged in user account, I have things like C groups applied to my processes and processes and stuff. So one of the other things you can do is you can come in here and add a couple of options. It's fine. With Find, there's always more options. Oops, there's a space there. So I'm using a logical operator called not, which basically
okay.
makes,
I was thinking not path seemed like a weird option, but now I get it. You're doing an operator for not.
Yeah,
Okay.
for not. So things that are not like this. Path sys and not path run. Right. So now I'll scroll all the way back. It doesn't show me any of those ones that are in the not paths. So why would you use something like this? Well, maybe you are going to make an archive of this person's files on your entire system before you delete them, right? Where like someone who's a little bit less sophisticated might only grab a copy of their home directory, not realizing that there could be other things like varsable mail for this person or things in some other directory that they made. So you can use Find to find all the files across the entire system owned by this person. You can even use things like not path to eliminate things that you really don't care about, like proc, so that you can then feed this into a tar archive to make a archive of this person's files. All right. The opposite is also true. So one that I use somewhat frequently is I look for files that are owned by no user. Now, why would I look for files that are owned by no user, Nate?
Let's see. I guess users that have been removed from the system, right? Would be
Could
one
be.
thing. Or, I mean, the paranoid side of me thinks that could be the indicator of some nasty business too.
Yeah. Hold on. That's why. User del.
You forgot to delete. You forgot to delete Joe.
Oh, interesting. Is he over here?
Joe is doing things. Naughty things are going on here.
Something.
Joe is running a rootkit on your machine right now. Mining crypto or something.
There we go. All right. So let me try it again now that that person's actually gone. That's why I was like, wait, that should be returning things.
There we go.
The
Super sketch.exe. I don't know what that could be.
Right. The other place where I find things are not often owned by users is when they get like pulled out of a tar archive or something.
Yeah.
And guess who lands files on your machine and pulls things out of tar archives for things that don't match your existing user accounts?
Naughty people.
So, right. Naughty people. The other thing that one might find is not just that they are not owned by a user. You could see things that are maybe not owned by a group because maybe they unpacked the thing as root, which does exist on your system. But when they're originally packaged up, they're owned by some weird group that wasn't present on your system. So I often use another option. -o no group. So here it'll find either files that are not owned by a user ID username, or are not owned by a group.
Super sketchier.
Yep, super sketchier.
It's convenient that the hackers had named their scripts so well.
Well, you know,
And also put their Windows executables on your Linux machine.
So I also wanted to do a listing of these files, right? So we can see that they're owned by a user, but not owned by a group. But wait a second. Because when I did it without the -ls, there were 2 files listed. But when I do it with the -ls, there's only 1 file listed. What gives? And this is where we get into more complex logical operands. So remember when we started, I said when you put things together, they're ANDed together.
Mm-hmm.
So when we read this, it says, I'm looking for files that are not owned by a user or not owned by a group and ls them.
Uh-huh.
But and is a higher logical operator than or. And so what we're really reading is I would like to find over the entire system things that are not owned by a group and ls them or not owned by a user. But we didn't ls the not owned by a user thing. So we only get the ones owned by a group. So what we can do is we can group together no user and no group with their or, and then take that selection and it with ls. And so did you know that find supports parentheses?
Oh, good.
So just like
Now,
you use
so now we
parentheses,
can so now we can put find commands up on social media to try to trick people into doing their operations in the wrong order, like they do with math.
could be. Exactly. So this is exactly like math, right? You need to do your addition before you do the multiplication that's later, but you have to have a way of saying this is the thing that has to be done first, and the way we do it is with parentheses, right? So, and parentheses also means something in the shell, which is why I have those backslashes, so they get past find. But notice that when I just add the parentheses, all of a sudden my ls is printing the right commands because
There you go.
right files because I've like grouped it together in a way that find understands. All right. So we found these super sketchy files.
Super sketchy.
Yeah. Should we just delete them?
Well, I don't know. I guess it depends. If they're super sketchy, I would probably want to take them for analysis.
Oops.
No, I wouldn't. I wouldn't execute them.
Well, I'm executing them anyway, but I'm executing an RM on them.
Okay.
But I'm not using -exec. I'm using -OK. So -exec will basically just execute whatever is in the referenced command. There you go. Executes it. -OK says, hey, I'm about to do this thing. Is that okay?
That's interesting.
And so you have to say, yes, remove that file. It says, hey, I'm about to do this thing. Is that okay? No,
That's helpful.
that's what I want to keep.
But it's super sketchier. Why would I keep it? Come on, Scott.
Well, that's the one you're taking for analysis, Nate.
Oh, I get it. I get it.
Right. So after this is done, I should only see one of those super sketchy binaries anymore because I successfully removed the other one with saying yes when it asked me if it was okay. So if you're doing an exec and you're worried about like, should I really exec it? Let me have one chance of introspection before I do the
one last chance. Well, that's really helpful, right? Because if these aren't sketchy files, if they're like, I ran a find that was supposed to delete a bunch of old log files, and it also caught the database file or something, right? And you're like, oh wait, no, I didn't want to delete that.
Right. Well, it's gone now.
Oh crap! Find didn't ask.
Yeah. All right. My last one. So I was going through the find man page because I was looking for like things that I had used before, and I didn't want to miss any that I have actually used in real life for doing different things. And I happened upon a really cool example that I have never used before, but I was like, oh, that's really cool. So.
Oh, there was chat about printf. Here we go.
Yes, fprintf. So what I'm doing is I'm using find to find files that are others have write access to. And in fact, before I do this, I need to change directory. Otherwise, it's not going to give me anything. There we go. All right, let's try it again. So I'm looking for files that are other user writable. And when I find those files, I'm going to print a statement. The statement
Okay.
is going to go into a file called world writable txt. And in that file, world writable txt, I'm going to put the mode of the file, its permissions. I'm going to put the user that owns it. And I'm going to put the path to the file name. And then a new line character.
Makes sense. Are all of these percentage and whatever for syntax outlined in the man page? Because that
They
looks
are
pretty
indeed.
hard to figure out. Of
They
course they
are
are.
and there's like a ton more besides
I
these,
bet.
right? This was like the example that was in the man page. Like I literally just copied and pasted the example, Nate. And so this is what we end up with in that file that I wrote,
Low
right?
effort, I tell you.
The permissions, the owner, the user owner, and the path to the file it found, right?
Yeah. Cool.
So
Look at all those evil permissions.
that's right. Except for the directory, which still has evil permissions, but in a different way.
Yes, evil in a less biblical sense.
So
Awesome.
my last example, I'm writing a report,
All
printf.
all the find you could possibly want. And Shantanu wants us to go into GDB on that executable. So maybe that'll be next week.
Well, I mean, what goes better with find than debugging executable commands? We can look like low-level system calls. That totally goes with find.
Yeah, totally. That's like almost identical.
All right. Any unanswered questions, producer Nate?
Let's see here. I thought there was one, but now I forget what it was. Oh, there was a question about why not use FD, but I don't remember what that was in reference to at this point. I think it was when you were doing the order of operations stuff.
I've not used FD, so I can't accurately answer that question.
Yeah, like I said, I don't have context, so I'm not really sure.
All right, so I think that's it.
I think that is it. We actually have a plan for the next show this time, don't we?
We do.
Do you remember what it is? Because I'm trying to look it up. Logs and audits.
Yes, logs and audits.
Logs and audits.
So we're going to be talking about reading logs, generating logs, managing logs, and also audits. Where audit, I think, is audit D in this case, Nate, if I'm remembering correctly.
I don't know. We haven't written up the show yet, but probably.
Sounds like a plan. So we'll do some auditing as well. And we actually, a couple episodes covered session recording with T-Log.
Yes.
And I think that's like kind of more effective than audits, but a lot of the security standards want audits so they can see like when somebody changes the permissions on a file, there's an audit notification that's made about it. But we could also get that from T-Log where we see somebody run the chmod command and we know about it. So
there was a question about C time and A time as we were talking about the next show.
C time is not creation time. C time is changed time.
Change time.
So yeah, so A time is access time. So last time somebody used that file for something. M time is modification time. So somebody went in and actually like changed the contents in the file, like they edited it or redirected output to it or something. C time is a property change. So if you update the permissions or the ownerships or something like that, the C time will also change. So it's a change time, meaning change the metadata or the properties of the file. But the file contents are not included in that because that would be a modification time.
Sorry, I'm responding to something in chat about satellite. We're probably not going to cover satellite on Into the Terminal. We do have other content regarding satellite, though, but it was in reference to compliance scans. We have done OpenSCAP compliance, so you can go back and find episodes on those. In fact, JScar in the chat was one of our co-hosts for that, so you can check that out.
Yeah, and there is actually several satellite videos already, and I think one of them does cover compliance scans with satellite.
There we go.
Eric did a mini series with Richard Rios. It was like 5 episodes on satellite.
Right.
That was one of the topics they covered. There's also in the videos of our channel a like 5-hour-long satellite video, which is those 5 episodes smashed together into one episode or one video.
Because who wouldn't want that?
Exactly.
Can't sleep at night? 5 hours of satellite. There you go.
So next week, we will be covering logs and audits. Don't forget to bash the like and subscribe so you get to know when we're doing these things, which is mostly weekly. Occasionally we actually do stuff like go to Summit. We don't have an episode, but generally weekly.
That is true. Generally weekly. That's a good promise to make. Generally weekly. I hope everybody has a great one, and we'll see you next week.
Bye, everybody.